So the word distribute means to pass out. For instance, if I had candy and I was going to distribute the candy, that means that I would give each one of you the candy, right? And hopefully you know that if you bring in treats to class, that you should give a treat to everyone, right? So it's going to work the same way with numbers, except that we're going to distribute or give out a number, and the group is going to be inside of parentheses, and we have to give that number to each thing inside of the parentheses. So let me show you what I mean by that. If you had 5 on the outside, and on the inside you have 11n plus 2. Now first let me point out that this is not an equation. There is not an equal sign. So we are not solving today. We are simplifying. Okay, we're simplifying today. And basically what we're doing is we're getting rid of those parentheses. We are going to take that 5 and we're going to do 5 times 11n, and we're going to do 5 times 2. Because again, we have to distribute it. We have to give it to everything inside the parentheses. So what would 5 times 11n be? 55n. And what would 5 times 2 be? 10. Now this is about as easy as it gets because we have whole numbers. We don't have decimals, we don't have fractions, we don't have negatives. So this is about as easy as it gets. Before we get into some more complicated numbers, I want to also review with you that it can be a number on the outside of the parentheses on the other side. For instance, you could have 3m plus 6 on the inside of your parentheses and then have a 4 back here. It's going to work the same way. That 4 is right up next to the parentheses, meaning we are going to distribute the 4 to the 3m and the 4 to the 6. So what is 4 times 3m? 12m. And 4 times 6 is 24. Now is that a positive or negative 24? And that is really why we put a plus sign in between the 12m and the 24. So again, this is simplifying. This is not solving. We are not solving for the variable today. All right, so let's do this when we have some numbers that are not as easy to work with. Let's say that we have 2.1 on the outside, and on the inside we have 5w minus 15. So let's do 2.1 times 5w. What is 2.1 times 5? 10.5, so then we're just putting that w after it. And what's 2.1 times 15? Now there's a negative sign. That's like a positive 2.1 times a negative 15. So that would be a negative 31.5. Okay? Let's get a little bit harder. Let's say we have negative 1.5, and in parentheses we have negative 82 minus 10. So let's think about this for a second before we start putting things in our calculator. We have a negative times a negative, which is going to make it a positive. We reviewed that yesterday. So that's why we reviewed that yesterday, to make sure we're all ready for this. So let's do 1.5 times 82. 123. So again, it's positive because it's a negative times a negative. And then same thing over here. That should be a positive 15, correct? So it's not just that you're bringing down whatever symbols inside the parentheses, you're bringing it down. We have to really think about, is it a negative times a negative? Is it a negative times a positive? Is it just a positive times a positive? The rules that we were doing yesterday, okay? And again, the sign in front of a number goes with it. So that's a negative 10, and this is a negative 82. Sign in front of it goes with it. And this, obviously, out front is a too dark green. Negative 1.5. So now take this one step further into algebra, we're going to write each fraction as a sum or difference. That's going to be our directions. So if I give you 2x plus 7 over 5. 2x plus 7 over 5. First of all, this is going to be the 2x plus 7 is going to kind of go together. We're going to keep that numerator together, and that's what's going to go inside of the parentheses. But we're not just going to put a 5 on the outside because that's not times 5. That means dividing by 5. So dividing by 5 is the same thing as multiplying by 1/5. So again, I'm going to say that one more time. Dividing by 5 is the same thing as multiplying by 1/5 because of the same change flip thing. All right? But we're not finished. What we want to do now is we want to distribute. So we want to do 1/5 of 2, and we want to do 1/5 of 7. And you can write your answer as a fraction. So don't use your calculator right now and write a decimal. Let's write it as a fraction. What is 1/5 times 2? 1 over 5 times 2 over 1, correct? Which would be what? 2/5. So 2/5 x. And what is 1/5 times 7 over 1? 7/5. And it's positive, correct? So that is the answer that we're looking for in these. We'll do another example, don't worry. I'm sure you've not seen this before. Do you have any questions about this example? It doesn't seem too hard when you see it, but I think that if you were just asked to do it, I would have no clue what they meant by those directions. So let's do 8 minus 9x over 3. 8 minus 9x over 3. What goes inside my parentheses? All right, 8 minus 9x. And what are we multiplying that by? 1/3. Very good. So you're using your example up there to help you. That's great. So now we're going to multiply 1/3 times 8, and we're going to do 1/3 times negative 9x. So what is 1/3 times 8? 8/3. And positive 1/3 times a negative 9x. Negative 9 over 3, which is just negative 3, correct? Negative 9 over 3 is just negative 3x. 1/3 times 9 over 1 is 9 over 3, which equals 3. That's where we're getting that from. So we just did the simplifying in our head. I think most of you would probably be okay with that. Do you want to try one of those on your own? All right, let's try one of those on your own. Again, this is kind of a new skill. How about you do 4y minus 12 over 2. 4y minus 12 over 2. 1/2 times 4 is 4 over 2, which is 2, so that's 2y. And then 1/2 times 12 is 12 over 2, which is 6. But it was a positive times a negative, so that's why it's a negative 6. All right, we okay to go on to the next thing? All right, good. So the next thing that I want to practice is, again, simplifying, but these are a little bit more difficult. It is just distributing. So the directions would just say simplify. It's not going to say solve. So in these problems, in this section, we're going to be distributing a negative sign. You may have done that last year. I've taught people to distribute a negative sign before. So I would think that you probably have done this one before. When you're distributing a negative sign, you can, if it's easier for you, think about it as being a negative 1. But you're really doing negative 1 times 20 and negative 1 times positive 4D. Okay? So what is negative 1 times 20? Negative 20. And negative 1 times positive 4D would be, that's it. It's really simple. You're right. Seems too simple. It's not, there's no trick to it. Now it looks a little bit more complicated when I put a lot of negative signs in here. So in this problem, we have lots of negatives, but we all know that a negative times a negative is a, so it should not be that big a deal. Negative times a negative 5 is a positive 5. And negative times a negative 4y is a positive 4y. And that's it. No big deal. Now you can use distributive property to do mental math. And I know I said, hey, here's a calculator, but you can use it to do mental math. And I want to see if you know how to use it using mental math. So let's see. So this is going to be mental math, meaning no calculator on this area. If you had something like 5.1 times 8, some of you just in your head line it up. Like some of you are doing this in your head, right? And there's nothing wrong with doing it that way in your head, but that's not really using the distributive property. What they mean by using the distributive property is breaking it into pieces by thinking about 5 times 8 and then 0.1 times 8. So 5 times 8 is 40, and 0.1 times 8 is 0.8, and then just combining those together to get 40.8. Raise your hand if you've ever done that mental math like that. You all are very good math students, so I bet you have, because you're comfortable with numbers. So that's like a shortcut to be able to do a problem, is to break it apart. And what you were doing there is the distributive property. What if you had 4 times 197? So again, we're breaking the 197 into place values. So 4 times 100 is, 4 times 90 is, 4 times 70, or 7 is, sorry. So now let's add up our place values. 4 times 90, right? That's okay. So again, that's breaking it apart. This is called expanded form, like when you do 100 plus 90 plus 7. Do you remember like maybe doing that in 3rd grade, 4th grade, 5th grade? Expanded form. It's breaking it into expanded form and then multiplying each thing using the distributive property. Okay? All right, we are on our last section of these notes. And the last section is going to be combining like terms. You should definitely know what I mean by this. And this is another thing in math that I like to do because I'm weird and like math. So I'm going to write an expression, and I want you to be thinking about what the like terms are, okay? So if I asked you what is the definition of like terms, how would you describe like terms? Very good. So she said it's like apples and oranges. You have variables. All right, so back to what your great answer was. Apples and oranges. You have terms that have variables, and you have terms that don't have variables. A term that doesn't have a variable, like the 2 and the -5, those are called constants. Because something that doesn't vary, which means change, stays constant. Okay? So you would combine your constants, and the sign in front of it goes with it. You would combine your constants, and then you would also combine your terms with the variable. Okay? Now, when you write this, the most proper way to write it is to have your term that has the variable listed first. Okay? That's kind of the proper way to write it. So let's combine 11x plus 9x, that's 20x, plus 3x, that gives me 23x. And now I'm going to combine my constants. 2 minus 5 is -3. And that is your final answer. There is nothing wrong with writing it -3, and that's a positive 23x. So, like this. That means the same thing. But I'm telling you that it's more proper, it's better, if you write the term with the variable first. Question, Matthew. Is it? Yes, you have time. Now, it's also very important. Yes, you have a question? Variable? Yes, let's do one like that. Alright, let's look at this problem. You're actually, in this lesson, you're not going to have any this difficult, but there should be no reason that you can't do them this difficult, okay? Especially when you've been taught it before and it's not that hard. Now, I know that there's a y, but notice how some terms have a y and some terms have a y to the second power. Those are considered different terms. Okay, so now we have apples, oranges, and bananas. Alright? So let's look at the terms that just have y to the second power. And we have another one down here. So let's combine those two terms, and you would get 8y to the second power. Now let's look for terms that have just a y. I only have one of those, so that makes it pretty easy. And then you have your terms that have no variable, so they're called the constants. 8 minus 4, which is a positive 4. And that is your final answer. Okay? So you cannot combine a y to the second power with just a y.